Now, the turning point. How we can identify the turning point? You know that the polynomial, if it's even, it will be like example like this. And as you can see, I have here turning point. I have turning point, turning point, turning point, turning point, right? And if I'm talking about odd, the odd, it will be like this. I have turning point here, here, and here, and here. How can I classify or identify how many turning points? I can identify turning point using this concept. Always use this concept in all the questions. Starting from now, always use this concept. A polynomial function f of degree when n is greater than 1 has at most n distinct real zero. Okay? When at most n minus 1 turning point. Means, look to the power here. Example. Let f of x is equal 3x to the power of 6 minus 10x to the power of 4 minus 15x to the power of 2. Now look to the highest degree. What's the highest degree here? It's 6, right? So that means the degree of this function, degree is 6. Now the turning point, it should be the power minus 1. So that means 6 minus 1, which is equal 5. Okay, so I have in this function here, given this function, I have 5 turning point. Okay, now maybe some of you will ask me, teacher, okay, if this is the graph, I don't have 5 turning point, I have 1, 2, and 3. Why it's not 6? Why it's not 5? I will tell you why. If we read complete reading here, then f has at most 6 real zeros, okay, and at most also 5 turning point. Example means, if this question, this polynomial I'm giving you in multiple choice and ask you how many turning point, you have to mention, of course, n minus 1, which is the power minus 1. So it will be 5. If the question asks you here to identify it, the turning point, try to graph the function and look to the turning point. Here is a 3, but you have to write 5 turning point. So always the turning point, it will be the power minus 1. So you don't have just to follow the graph. Means the number of turning point, okay, from the function, always it will trick you. So if the function, okay, again, if you graph the function and you find it's not 5 turning point, it's a 3 or 2 or 1, okay, so you don't care about the graph, you care about the rule. The rule said it's 5 turning point, so it's 5 turning point, even if the graph doesn't have. Okay, now also the zeros, we know that the power represent how many zero do I have. So of course, because it's 6 degree, of course I have 6 zeros, right? And as you can see, I have here only 1, 2, 3 zeros. I don't have 6 zeros here. But of course, if the question asks you how many zeros, you must say I have 6 zeros. But when you solve them, you will not get the 6 zeros. Okay, it's fine for that, but you have to mention 6 0. So starting from now, you look to the degree for the highest degree, and you look to the turning point, which is the degree minus 1. Okay, now let's start taking some examples here. Now, to identify the zeros, here we need to find the zeros for every function. And to find the zeros for every function, I have to replace y with 0. Okay? Now, as you can see here, f of x, so let's replace f of x with equal 0. So I put f of x equals 0. Now, how do I solve this? Always look to the common factor. When you need to find the zeros, common factor. The common factor between every term here is x, because here I have x, I have x, I have x. So take x as a common factor. So when you take x from every part, it will remain x squared minus 5x plus 6. Now, what's how you can factor this? The factor of this is 3 and 2. Okay, and because b is negative, so it will be negative 3, negative 2. So this is the bracket. So the zeros now 0, 2, and 3. If you need to do sketching for this polynomial, so always put this one. Okay, then put the zeros. So I have 0, I have 2, and I have here a 3. Okay, so now look to the degree. The degree is what? Degree is a 3. So that's mean this one is odd. Okay, leading coefficient here is 1, which is positive, So if it's odd, and if it's positive, it's start down, ends up, right? So start from down, go from the first point. Between any 2 points, you have to do turning point and go through every point. Then between 2 points, do turning point. Then you go up like this. So the graph will be like this: starts down, ends up. This is the graph. Now, I don't care about how much going up, how much going down. We don't care about that. Just I care about the sketching. Okay. Now, how about this question here? Now, as you can see, we need to find the zeros. So turn f of x to equal 0. X to the power of 5 plus 3x to the power of 4 plus 2x3 equal 0. Now, always look to the common factor. What's the common factor here? The common factor is x to the power of 3. X to the power of 3. Okay, and if I take x5, it will be x2 plus 3x plus 2 equal 0. Now, what's the factors for 2 if I multiply them? So I have 2 and 1, and if I add them I get 3. So the first 0 is x3, so x plus 2 and x plus 1. So the first 0 is x equal 0, the second is x equal negative 2, then x is equal negative 1. Now if I need to do the sketching for this graph, okay, so the sketch first put the zeros. So I have x equals 0, I have negative 1 here, I have negative 2 here. So now look to the power is odd, okay, and the leading coefficient is positive, so it will start down, ends up. So starts down from the first point, go through the second point, turning point now, then go the third one, it will be like this. Now if you look to the graph, look to the power is what? Is 5, okay? But as you can see, how many x-intercept do I have? I have a 3 intercept from the graph. So we don't care about the graph now, we care about the function. It's saying 5 degree, okay? So 5 degrees, so that's mean I must have 5x intercept. And how many turning point? I have 4 turning point, okay? 4 turning point and 5 degree. Now, let's go next. Here, let's take this example. This different example. Now, always, as I told you when you start, take the common factor. Do I have common factor here? No, I don't have. But look to the power. As you can see, the power here is both of them are even. Okay, we know that you studied this one before. If x squared plus 2 if you know the standard form of the quadratic, the standard form is ax squared plus bx plus c equals 0, right? If I write another one is and if I need to factor the quadratic, it should be x minus or plus something, x minus or plus something, right? Now, if I give you the same example, but x to the power of 4 plus bx squared plus c equals 0, this one also, let's say it's considered like the quadratic function. So you can deal this one as a quadratic of this. So when you just factor this normally as you factor the quadratic, okay, well, but the only change will be here x plus or negative, x plus or negative, x plus or negative. The only change here it will be because here x to the power of 4 and this x is x to the power of 2, so you have to give this one here x to the squared and here is x squared, okay, and you take everyone equals 0, then you find the answer. So this is what this is the easiest way to solve this equation. But the book has the rule said, okay, if you go up here, the book said there is another way of solving or a rule. If you have x to the power of 4 and x to the power of 2, just replace every x square with y square, with u, okay? So it means here I have x, now if I say y, if I say u equal x square, now then if I say u squared is equal what? U to the power of 4, u to the power, example, to the power of 3, so it will be x to the power of 6, okay? So as you can see here, every u represent 2 x's. Every u 2 x's. Okay, 1 u 2 x's. 2 u's it will be 4 x's. 3 u's it will be 6 x's. So now every x squared replace it with u. So I have here how many x? I have 4 x's. So I replace it with u squared. Here I have how many x's? 2 x's. So I replace 2 x's with 1 u. Now, is this one in the standard form of the quadratic function? You know, this is the standard form of the quadratic function. Okay, now you just factor this one. At the end, okay, you just replace them. This is what you see here. So after they replace u, then they make it like this. So you don't have to do the u from the beginning. You can just start doing like what I did here, and that's enough for me. Now what you have to do, you take the first bracket equals 0 and x squared plus 1 equals 0. So now minus 1, so you cancel. So x squared equal negative 1. Okay, then you use square root for both sides. So x is equal, I have negative under the square root, so this is imaginary number, right? So the imaginary number, I can't graph the imaginary number, so we ignore this part. Okay, we have to write it, but we ignore it because we can't have a negative. So as you can see, we wrote it, okay, but we can't graph it because it's imaginary. Now in the second part here, I have x squared minus 4. So let me write here x squared minus 4 equals 0. So plus 4 for both sides. Now x squared equal 4. Then we use square root for both sides. So x is equal negative 2 and positive 2. This is what you can see, negative 2 and positive 2. Now if I need to graph this function, okay, let's do the x, y and x intercept. Now look to the power, or let's say before the power, replace the zeros. So the first 0 is equal to, the second 0 is equal negative 2, and as you know, this is a major number. I can't plot it on the graph, so just ignore it. Now after we plot, look to the power here is even, right? So if it's even, it will start up, ends up. Look to the a is positive, so still up and up. Now when I start up, I go through the first point, and then I have to turning point, then I will end like this. So it starts up, ends up. So this one is like a normal parabola. Okay, I hope you understand this. Now let's take this example here. Now this example here, always think about the common factor. The common factor here is x to the power of 4 and 9. So if I take 9 x to the power of 4 as a common factor, so it will be x to the power of 2 minus 4, okay, equal 0. Now take the first term, 9x to the power of 4 equals 0, and take the other term, x squared minus 4 equals 0. So this term here, if you divide by 9, we divide by 9, so we cancel. So the 0 divided by 9 is equal 0. So x to the power of 4 is 0, so that means x is equal 0. Here, if we plus 4, we plus 4 for both sides, so we cancel. So x squared equal 4, we use square root for both sides, so x is equal positive or negative 2. Okay, so I have 3 zeros. Now if I need to graph the function, okay, do the sketching, start plot the zeros. So the first 0 is here, then I have positive 2, then I have negative 2 here. Now look to the degree. The degree here is even, so when it's even, we start up, ends up, and a is positive, so also we start up. So we start up from the first point, okay, then I have to go through the second one, then I have to go through, so look to the graph starts up and ends down, and this is not the end behavior for the even function. So what should I do? So there is a mistake here in this equation. Let's fix this mistake. What's the mistake that I have here? Now we have something here, we call it repeated zeros. Okay, so what is the repeated zeros mean? Repeated zeros, or we have another word for it, which is, we call it multiplicity. Multiplicity. What's the multiplicity or the repeated zero means? The repeated zero or multiplicity means, if you look here to the, if we have x to the power of 2 equals 0, or x to the power of 4 equals 0, when you simplify, you reach to this step, I mean, or x to the power of 6 equals 0, x to the power of 8 equals 0. So that's mean this x, okay, how to solve, if I ask you how to solve this, you need to use square root for both sides, right? So to cancel the square, so that's mean x is equal positive or negative 0. So if I ask you, is there such thing that positive, negative 0? No. So that means 0 is repeated twice. One is positive and one is negative. But in math, we can't write positive, negative 0. So we cancel both of them and we write only 1 0. So that's why we call it repeated 0, because this number here is repeated twice. Why twice? Because it's for the power. Same thing here, if I need now to do this one, I have to use root of 4 for both sides, so I cancel the root with this one. Here, how many zeros do I have? Here I have 4 zeros, okay, I have 4 zeros, so the number 0 is repeated 4 times, okay, same thing here. Here the 0 is repeated 6 times. So when you reach to x to the power of number, okay, and you find this 0 is repeated, so this point, okay, which is the 0, this point, it will be the turning point. You know that when I need to graph, the graph example, the graph, it will be like this, grow through this point. But when this point is multiplicity or repeated, so the turning point, it will be at the same point itself. So you have to do turning point on that. So when this 0 or this point is multiplicity, okay, so that means this point will be your turning point. If it's like this, or it will be like this. So you can't go through the point. No, this is wrong. You have to go, this point will be multiplicity. So this is what you can see here. As you can see, x equals 0 is multiplicity. So this point here is multiplicity, repeated 0. So now when I start up, go through the first point, -2, and when I go the 0, should I go through the zeros? No, it's wrong, because 0 is multiplicity, so the 0 will be my turning point. So I have to turn at the 0. Okay, then turning point between this one and go this one. So now the graph, it become like what I know, which is starts up and ends up. Okay, another way of examples of the multiplicity, if you have x minus 2 squared, or if I have x plus 4 squared, so also this one is considered multiplicity. Or let's say x minus 6 to the power of 4, also this one is multiplicity. Okay, but how about if the x is equal to 3 equals 0, or x to the power of 5 equals 0, or let's say x example minus 3 to the power of 3. Are of these considered multiplicity? No, these are not considered multiplicity. The multiplicity only and if only the power is even. Okay, if the power is even, as you can see in these examples, so these points will be your turning point. These are considered multiplicity. These are not considered multiplicity. Okay, I hope you understand this. Now let's take last two examples here. Okay, state the real 0. So the first here, if we take the common factor, x squared is a common factor. So if I take x squared, and also I can take the negative as a common factor. So if I take the x as a common factor, so it will be x squared plus x minus 2. So now we can factor -2. What's the other factor of -2? To get 1. So it's 2 and 1, and you can say it's -1 here. Okay, so this is what you can see. So the first point, negative x squared is equal 0. Then x, so that means x is equal 0. Okay, then I have x is equal 1 and x is equal -2. Now if I ask you, is this point multiplicity? Yes, so this one here is multiplicity. So this point, it should be a turning point. Okay, why? Because x to the power of 2, which is even, equals 0. Okay, now if I need to graph or sketch this function here, okay, so the first point should be x equals 0. The second point is x equal 1. The third point should be x equal -2. Now this, look to the power. The power here is even. So if it's even, it starts up, ends up, right? But a here is negative, so it should starts down, ends down. Okay, so we not start up, ends up. So it starts down, go the point, then we go the 0. Should I go this through the 0? No. Why? Because 0 is multiplicity. So at the 0, so this 0 would be my turning point. So then I go like this. So this one is the graph. I hope you understand. Now try with this one. This one also is easy. Let's take x as a common factor. So it will be x squared and x squared plus 5x plus 6 equals 0. Now what are the factors of 6 that give me 5? So I can say 3 and 2. So now it will be x squared, x plus 3, and x plus 2 equal 0. So the first x squared equals 0. So this is multiplicity. This is a turning point, multiplicity, turning point, because x squared, here is x equal -3, here x is equal -2. Okay, now if I need to sketch my graph, okay, the sketching, now plot the 0. So the first one is 0, the second one here is -3, okay, then here we have -2. Now look to the power. The power is what? Is even. So even function. Now it starts up, ends up. also a is positive, so still same thing. So we start up, go through the first point, then we go to the second point, then at the 0, should I go through the 0? No, the 0 will be my turning point, so I have to turn point on the 0, so the graph will be like this one here. So it starts up and up. I hope you understand this. This is what the whole lesson talking about. Now it's your turn. Try to solve these questions by yourself, and if you find the zeros, and do small sketching, okay? And if you need more exercise to practice, sorry, let me remove this, okay, for you. These also more questions to practice, okay? If you need any help, please call me. Now here, the last part here, if you need to graph the polynomial. So the graphing polynomial, same thing as we learned. It's just you identify the leading term, the leading coefficient, okay, and you solve it as normal. For the example, let's read the question together. For the polynomial fx equal this, first, number A, apply the leading term test. So this is apply leading term test. So let's apply the leading term. Applying leading term test means you have to look to the A, okay? And look to the A. Let's identify the degree. As you can see, look how many x do I have. I have x here, 1, and I have x here, 2, and I have here x is 3. But it's squared, so that means this x is repeated. So I have 1, 2, 3, and 4. So what's the degree for this function? The degree is if it has degree of 4. Okay. Now what's the leading coefficient? The leading coefficient is the number, okay, that if you multiply all of them, so okay, let me show you how to do it. Now this is x, okay, this is x, and this is x squared, right? Sorry, I forgot to take the 2. This is the whole term together. This is x, this is 2x, and this one is x repeated, so that's me, I'm talking about x squared here, right? Now multiply all of them together, so this is x and this is 2x, okay, x times 2x times x squared, multiply all of them together. So as you can see here, x times x squared is equal what? X to the power of 4, and don't forget the 2. So now we can say the degree is 4 and the leading coefficient is what? Is 2. So this is the leading coefficient, which is equal to, and the degree is equal 4. Now because the power is even, so it starts up, ends up. So when I need to talk about the limit, so the limit when x approach negative infinity, it's up, so positive infinity. When limit x approach positive infinity, f of x is equal positive, because also it ends up. Okay, now number 2 of the question, it's asking determine the zeros and state the multiplicity of any repeated zero. Okay, now how can I know the repeated zeros? I need to solve the question, and as you can see here, look to the question. The first, let me write it here, x, okay, 2x plus 3 and x minus 1 squared. So the first 0 is x equals 0. The second 0, 2x plus 3 equals 0, so minus 3 minus 3, then 2x equal negative 3, so divide by 2, so x is equal negative 3 over 2. So this is the first 0, this is the second 0. Now the third 0 is x minus 1 squared. So that's mean I'm talking about, okay, x equal positive 1. And this point here should be what? Multiplicity. Why this one is multiplicity or repeat 0? Because I told you when x squared equals 0 or x minus any number square equals 0, so this one and this one considered multiplicity, okay? So this one x plus 1 is also considered as a multiplicity. So now if I need to graph the function, you don't have to make this table. This table is not important. I will not ask you about it, okay? Which is find a few additional points. I don't need to find additional more points. Now let's go to the last part, which is graph the function. A graphing function, I will just ask you to sketch it. So now you know how to sketch this, okay? You know how to sketch this graph. This point, you have the zeros, okay? The 0, this one here, okay? Now plot the point. The first one is 0. The second one is negative 3 over 2. Negative 3 over 2 converted to decimal to know how to graph it. So means negative 1 point, I think, half. Or negative 1 point half. So it should be here. Negative 1 point half. Okay. And here is positive 1. Okay. So now look to the power. The power of the function is even. So it's even because it's even, starts up, ends up. Okay. And the leading coefficient is also positive. So we start up. we go through the first point and we go through the second point, and one, should I go through the one? No, because one is what is multiplicity. So at one I have to do turning point and goes up like this. Okay, this is what you can see in the number D. Is it same graph? Yes, it's same graph. I will not ask you how much you go down or how much you go up. It doesn't matter for me. Now try to do these questions by yourself. Try to graph them. You can solve it easily, and if you have any question, please ask me. Okay, and this is the end of the lesson. These are some questions. Try to solve them or try to solve the even number of the question. Have a good day. See you. Bye bye.